Hello, everyone. Thanks for joining my presentation. I am Arun, a cloud platform engineer, and I'm going to talk about a GitOps-driven, adaptive, closed-loop multi-cloud governance framework for drift correction, policy enforcement, and self-healing. So, multi-cloud provides resilience and prevents vendor lock-in, but it still introduces complexity in IAM policies, telemetry, and the way we provision the cloud resources. And that results in fragmented governance and increased operational effort. So the governance framework combines GitOps, policy as code, IAC, the infrastructure as code, and self-healing automation to move governance from reactive auditing to continuous and auditable correction. So I will cover the problem statement, the proposed architecture, the control loop design, evaluation results, and the key operational lessons. Yeah, the problem statement, like enterprises or organizations adopt multi-cloud strategies to increase resilience and accelerate innovation. So the ability to use the best services from different providers help avoid vendor lock-in and creates flexibility. But the challenge is that each cloud has its own identity systems, APIs, policy frameworks, and telemetry models. So instead of having a single unified control plane, organizations end up like managing multiple tools, standards, and policies to manage the multi-cloud infrastructures. So the key challenges that they face is like configuration drift. The changes are applied manually or inconsistently across cloud environments that can lead to mismatched state. The second one is operational overload. So that operation teams spend excessive time managing, manual or duplicate process in multiple cloud platforms. The other one is lack of visibility. So teams may not have, complete visibility or observability that provides a clear end-to-end view of the systems. The other one is like policy fragmentation. So different enforcement models and guardrails in each cloud can lead to inconsistent governance. The other one is the slow threat response. So when incidents or drift occur, the teams can struggle to correlate the data and respond quickly across multiple cloud providers. So, in short, the multi-cloud provides agility and resilience, but without a strong, cohesive governance model, it can create complexity, risk, and slower response times. So the proposed framework actually extends GitOps beyond just application deployment into infrastructure and multi-cloud governance. The framework closes the loop from detection to correction through event-driven GitOps automation. So it's actually inspired by the map-K control loop, and it is built on three core tools: the Argo CD, Crossplane, and OPA Gatekeeper. For all the layers, the Git is the authoritative source of truth to maintain the desired state of the infrastructure. So the foundation of this framework is declarative governance. So infrastructure and application state are defined as code and stored in Git. So the infrastructure as code provides consistent provisioning definitions, while GitOps continuously compares the desired state in Git with the actual production environment or their resources that are in the live state. So Git becomes the authoritative source of truth for review, rollback, traceability, and evidence of compliance. This reduces dependence on manual tasks in cloud operations, and that makes a drift easier to detect. So in a multi-cloud environment, the same governance pattern can be applied consistently across cloud providers. Yeah, the first tool to talk about is the Argo CD. The Argo CD act as the GitOps controller that continuously compares the live Kubernetes state with the desired state stored in the Git repositories. So when resources become out of sync, Argo CD can report the drift, and when enabled, it automatically reconcile it. In this framework, Argo CD deploys application resources like as Kubernetes objects through a controlled pull-based workflow. So it also supports rollback, progressive delivery, sync phases, and sync waves for safer deployment methods. So next is the crossplane. So crossplane is actually a unified control plane that turns cloud infrastructure into Kubernetes managed resources. So the platform teams define reusable abstractions such as the XRDs, like nothing but the crossplane resource definition and composition. These are the components of crossplane. The users can request resources through the request claims, the XRC files. So this creates a controlled self-service model where teams can provision infrastructure without directly managing the provider-specific complexity. So the crossplane actually reconciles the actual cloud resource state against the declared specification and helps correct the drift. So in this framework, the crossplane is a bridge that connects the AWS, Azure, GCP, and on-premises resources into the GitOps governance model. Yeah, the other tool is the OPA Gatekeeper. This tool provides policy as code enforcement using rigor-based constraints or policies. So it validates the Kubernetes objects and cross-plane claims before they are admitted or like provisioned on the targeted environment. For example, like policies can require encryption, approved regions, mandatory cost, tax, and safe provider configuration usage. So Gatekeeper also supports audit mode, which helps detect existing any existing violations. Those exist that can appear later due to the configuration drift. So this is important because policy drift can be as risk as configuration drift. So this is the reference architecture. So in this architecture, we have like two Kubernetes clusters. On the left side, we see the Argo cluster, where we have the Argo events, Argo workflows, and Argo CD. So the Argo events and Argo workflows take care of the CI process to build the images before the Argo CD can deploy the Kubernetes objects on the target environment. So the other cluster, we have the OPI Gatekeeper and the Crossplane. For these two Kubernetes clusters, we have the HashiCorp Vault that can be used for storing the confidential data like secrets. Yeah, and this is the workflow of this architecture. So when a developer or any teams initiate or request by initiating a Git pull request, they commit that request onto the Git app repo or like code repo. So once a user places a request, so the Argo events detects that the code or request uploaded onto the code repo, and then it starts triggering the workflows using Argo workflows. The Argo workflows performs the CI process. It builds the XRC, manifest files, which is used for deploying the cloud resources. And then once it builds that excited manifest files, it's uploaded to that deployment repo. So once the files are uploaded to the deployment repo, the Argo CD takes care of fetching that manifest files or the deployment files and sends it to the for deployment. Like the OPA Gatekeeper sees those files for deployment, and then it evaluates like with the defined policies whether the files are meeting the policies defined. If any of the requirements or the request is violating the defined policies, it will terminate that request. It won't allow to proceed further to reach cross plane for the deployment. So if that file got approved or it is evaluated, and then the OPA Gatekeeper sends that request to Crossplane, and Crossplane reviews that deployment files, and based on the configuration, it provisions the cloud resources on the desired environment, like AWS, Azure, or GCP. Let's we talk about the closed loop governance mechanism. So the framework implements an adaptive closed loop governance mechanism directly inspired by the MAP-K model. So in the first phase, like monitor, Argo CD detects the out of sync status, and then Crossprint reports the condition changes, and even the gatekeeper highlights the policy violations through audits. The second one is the analyze. Here, the signals are correlated, risk is classified, whether it's low, medium, or high, and decide whether to auto remediate or route to a pull request workflow. The third one is plan. Here, the remediation strategy. If a remediation strategy is considered as considering the risk level, dependencies, and organization policies, then we can prepare the required sync or pull request actions. The other one is the execute. Here, low and medium risk drift can trigger immediate automated self-healing. So the high risk issues or drifts create auditable pull requests for human review and approval. So the other one is the knowledge. So Git is always the authoritative source of truth. So every remediation action is versioned, traceable to specific policy, runbook, and Git commit. So next, let we talk about the evaluation and the key outcomes from this. So the evaluation used drift injection data set with the 600 cloud resource drift events across multiple managed resources. So the event assisted data adaptive strategy to achieve a P95 cloud detection of about the 105 seconds. So it achieved the P95 auto remediation time for about like 410 seconds. And then provider read calls were reduced by roughly like 50% compared with 10-minute polling. And also out of like 86 drift events were classified as low or medium risk, and they were remediated. Um, and also of those auto-remediate events, like 90% of them completed within 5-minute SLO. So the key takeaway is that the adaptive reconciliation balances the detection speed, API efficiency, and change control safety. So, what are the operation lessons learned from this? So, there are like three practical lessons are important before adopting the framework in any live environment or production environment, like controller, production, tenant isolation, and traceability. So, the controllers must be protected with rate limiting, adaptive backoff, reconcile rate budgets, and admission control backpressure. So multi-tenancy must be enforced consistently through Argo CD app projects, Kubernetes RBAC control, gatekeeper constraints, and cross-plane provider config. So every remediation action should be traceable to the policy version, runbook, and git commit. And also the break class procedures should remain available, but with human, and it is also important to have human approval and auditability. So the main conclusion, and what we learn from this framework is that the closed loop GitOps can reduce exposure to drift while strengthening the reliability and security. Thank you.